Sine, cos, and tan, right? Sine whatever, cos whatever, and tan whatever. The problem when you're trying to work with them in identities or in equations is that they don't mix, right? Like if you think back to your algebra days, right, and you're like collecting like terms, these are unlike terms. You can't actually get them to interact with each other unless you do some kind of conversion first. And you've been doing that when you're practicing with identities. You turn cos squared into sine squared, 1 minus blah, 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 blah. So you've got to do some adjustment, right? Now this problem of them being unlike is very similar to the problem of fractions. Now, these fractions, they can't talk to each other either. They are unlike terms. They can't interact unless you convert them to something first, right? Sorry, I forgot to move this. This will make it sound a bit clearer. So what will we convert them into? What we want is a common denominator, right? So what's the common denominator that I would choose here? I would choose a 12th, right? So this is 3 over 12. And this is 2 over 12, right? And now they can talk and you can get an answer, okay? So you happy with that? Now, here's the important things to notice, right? Number one, 12th, right? That's not unique. There are plenty of other common denominators that I could have chosen. For instance, you know, when year 7 first learns to do this, the classic way they get a common denominator is you multiply, right? So the first thing that they might do is say, oh, well, 24ths, okay? So this would become 6 24ths plus 4 24ths, and you would end up at the same answer once you simplify out, okay? So common denominators are not unique, but some are better than others, right? Does that make sense? Now, the question I want to pose to you, and this is I'm trying to segue in rather than give you this concept and just be sort of, here, just do this. Why? I don't know, because I said so, right? What if we could get a common denominator, just like we have for fractions? What if we could get a common denominator for trig functions? One kind of, you know, language that they can all speak, and then you can just shove them all together, simplify out, and it'll all be happy, okay? Now, I don't know about you. I posed this question to myself, and when I thought about what common denominator could I get for sine, cos, and tan, the first thing that came to my head is sine, because sine is kind of like the basic function. It's where cosine gets its name from. It just means complements sine. And tan, as you know, is just a combination of the other two, right? So let's just imagine for a second, and I want you to write this with me, right? Let's try and get sine x as a common denominator. How would it work? How could we get cos and tan in terms of sines, right? Well, just to make things easier for us, let's let sine x be something shorter, okay? Let's let it be s, just as shorthand, okay? Now, let's tackle cosine first, because they are very close together. Sine and cosine are most easily related through the Pythagorean relationship, right? Sine squared plus cos squared equals 1. We get that from the unit circle, right? So if sine squared plus cos squared is equal to 1, right? And I want to get cos in terms of sines, right? I'll kick that sine squared over the other side. Okay? In fact, I don't even really need to write sine squared. I can just write s squared. And then if I want cos on its own, I take the square root, right? But of course, you got to be careful, right? When you take square roots of things, you got to realize there's two solutions to a quadratic equation. So I'm going to get this. Let's pause on that for a minute. Let it sit. What about tan? Well, if I know sine and I know cos, tan's pretty easy. Tan's going to be the ratio between those, right? So it's going to be sine on cosine. So that plus or minus, let's just let it hang out on the top because that's a more natural place to put it. Plus or minus s on that we know square root thing. Okay. So this is one way to approach the problem of getting a common denominator between all of them. Now, if I see sines and coses and tans in an identity, I just turn them all into s's, right? But the problem is this pesky plus or minus, okay? Because you're like, I don't know which one it's going to be. Which one it's going to be will depend on the value of x. So if x is within a certain range, it'll be positive, and if it's within another range, I should say domain, it'll be negative. Now, that's a real problem. That means every time you use this method, you've got to do cases. That's a pain. Not only is it time consuming, but it's also a very error-prone way to do things. Okay? So, sine's not a good choice for common denominator. you can probably imagine if we chose cosine instead, you get the same problem, right? It's just a little bit rearranged and it's C's instead of S's, okay? So what's a better common denominator? Well, after a lot of playing around, okay, it turns out that tan of x on 2. This turns out to be a really, really good choice. Then you're like, huh? Really? When I was taught this, they call this t, and so the whole concept under this is called t results. Right? When I was taught this, and in most textbooks, they just start off like this. They say, let t equal tan x on 2. And then they start to produce all this, all these formulas because of it. And they're like, well, why? I was like, trig is hard enough already. Why are you introducing weird, arbitrary rules in, which they don't make things any easier for me, it seems. They're more confusing. Here's why. It's because all the other alternatives suck. They've done the work for you and already worked out this is the best one. Okay? So even though textbooks may seem abrupt, right, which is confusing, they're actually trying to do you a favor. They're sparing you the process of working out that all of these options are not very helpful. Okay?
So what one isn't the best? That's another way to...
I'll show you. No common denominator is without faults. So this way of doing it, or cosine, or half angle results like we're using here for sine or cosine, they've got this plus or minus problem. This has its own problem too, but as you'll discover, it's a pretty simple problem to get rid of. Okay, but we'll probably actually deal with that next week. We'll see if we get there.